Hi, and welcome to Data 602 Advanced Programming Techniques. My name is Jamil Sheikh, and I am super excited to be your professor this semester. In this video, we'll be covering two things. The first is what you can expect to get out of this course, and what this course entails, and what will be expected of you, such as assignments and projects. I will be covering this material fairly quickly, but since you have control over the pause and play button, you can always repeat any section of this video when you want. So with that, let's get started. Let's look at this course from a bird's eye view. We'll be covering several important areas for you to dig your teeth into. We'll start off with learning the basics of Python first. Now, if you're already familiar with Python, this may be redundant, but you may wish to use this opportunity to strengthen your core understanding of the language. If you are not familiar with Python or have just heard of the language, then these first few weeks are going to be absolutely crucial. Python is a very easy language to learn, so I don't expect you to have too much trouble learning this. But since everything else in the course builds on understanding Python, you want to make sure you can allocate the right amount of time building this foundation. We'll then transition into studying Python data structures. Now, Python has data structures that are native to it, like lists and dictionaries, and also has third-party libraries that have become the de facto libraries to use in the world of data science. In this course, we'll study two of these libraries, namely NumPy and Pandas, which use advanced data structures and techniques. Both are a lot of fun. After that, we'll look at ways to present or visualize our data analytics. Data analysis is useless if there is no way to present the results in a manner or format that is easily consumable or understandable by a user. So in this section, we'll look at Python libraries like matplotlib that help us do just that. Next, we'll look at databases, repositories where data reside. We'll look at SQL databases and also have a look at NoSQL databases like MongoDB. We'll then jump into machine learning and computer vision algorithms that can be used on data sets to help us produce insights, predictions, or recommendations. Finally, we'll take a little detour into using another language popular in the world of data science called R. Now let's break down the work for this course. The course will have 4 required assignments and a final project. In addition, there are 4 books that we will be reading from. Now don't worry, we won't be reading all 4 books cover to cover, but only select chapters from each book. You can expect about 80% of the material to involve Python and about 20% involve R. In addition, there will be some required reading on special topics and readings related to tools like Docker and Git. If you are familiar with these tools already, then you have a little less reading to do. Now, if you're fired up and ready to get going, then I've put together a convenient list of things you can start on right now that will give you a jump start on the class. The first thing you should do, and this is required of every student, is to complete the assessment. The link to the assessment is listed in the syllabus on Blackboard. The purpose of the assessment is to give me an indication of the competency and comfort level the class as a whole has with the different technologies we are using. That will allow me to calibrate how I conduct the class and provide the appropriate level of support where you most need it. The second thing you should do is install Slack on your desktop and mobile phone. Slack is a free real-time chat and collaboration tool, and I especially love it and will rely on it for the class. On the screen, you'll see the URL for the Slack group that you will join. When you do sign up, please try to use your name as your Slack ID so that it's easy for me to track who is who, instead of using an alias or a name like DataGuy123. Next, make sure you download the books mentioned in the syllabus. The books are free, at least for now, so please make sure you grab a copy as soon as you can. There will be 4 books, and we will be reading chapters from each book, starting with the book titled Thinking Python. After you've downloaded the books, make sure to set up a GitHub account if you don't have one already. You can get a free GitHub account using the link I've listed in the syllabus. GitHub accounts are generally free, but the link I have listed will allow you to use the premium option, having private repositories also for free. Next, you'll install Python and R. Now, you can install Python and then install a bunch of libraries one by one, and then that install will take some time to complete. An easier way is to use what's called Anaconda, the Anaconda distribution. With Anaconda, you download one installation package and it installs a complete Python and R setup for you, including the libraries we will be using in this class. You can find the URL to download the Anaconda distribution in the syllabus. If you got your Python all set, then you should make sure you have Docker installed. Now, if you are not familiar with what Docker is, then be sure to see my video on Docker that covers the basics and concepts. If you are familiar with Docker, then that is fantastic. Either way, you should install Docker and check the installation task off your list. Next, make sure you bookmark the scheduled tracker spreadsheet. This spreadsheet is a Google Doc that has a week-by-week breakdown on what the reading assignments are, what may be due that week, and if there are office hours scheduled. It is a great way to track your progress and the progress of the class. Grading for this course is broken down into 3 components. The first is the final project, which accounts for 40% of your grade. We'll discuss the final project in a few minutes, but the main takeaway here is that it's a team-based assignment. Another 30% will be allocated to the 4 assignments. Each assignment is to be done by the individual and is not a team or collaborative exercise. And the last 30%, a whopping 30%, is allocated to what I reluctantly call participation. What I really want to see is classmates helping other classmates solve problems, which can include issues like installation or understanding how broadcasting and NumPy works. Everyone gets this 30%. It's yours to work down by not participating. So I really look forward to seeing you all create the real-time collaborative experience, especially on Slack. There will be a few tools you'll need to be familiar with. The first is Spider IDE, which is an IDE for Python. Now, it's not required that you use this IDE. In fact, you can use any IDE you wish for your coding. However, some of my presentations will be using Spider IDE, and if you're new to Python, then staying in sync with those videos by using Spider IDE may be useful, at least in the beginning. The next tool that you absolutely must know how to use is Docker. And as I mentioned previously, if you're not familiar with Docker, you can watch the video I've created on Docker and look at the syllabus for links on docs related to Docker. Git is a source code management tool, and you will need it to interact with GitHub. Again, if you're not familiar with Git or GitHub, then look at the syllabus for helpful links on documentation on Git. Finally, we'll be using Flask, which is a Python-based web framework that lets you build web applications quickly. In this course, the emphasis will not be on your ability to create web applications, but using the web as a means to present analytics. The web is just the means and not the ends. It's important for me to reiterate that if any of these tools are not familiar to you, then you should allocate some time early in this semester to getting mastery over them as quickly as possible. None of these tools are overly complex. They just require a little bit of time to get familiar with. Assignments will be due on average every few weeks. There will be 4 assignments that you will be responsible for. It is important to remember that each assignment will build upon the previous assignment and that they incrementally get more complex and evolve. Therefore, you should make sure that you have a strong showing for the earlier assignments. The first 3 assignments will progressively evolve an equities trading system. For the first assignment, you will build a console-based trading and P&L system using Python and libraries like NumPy and Pandas. The second assignment will expand on the first and shift the application to the web and data visualization capabilities. The third iteration of the app will include time series analytics of the trading and P&L statements. Each assignment is described in detail in separate documents, and links to those documents are available in the syllabus. The final assignment uses R and a subset of the data produced in assignment 3. Now, what matters to me is that you are delivering something that demonstrates your expertise with what you've learned as best as you can. This includes things such as using the right data structures in the right places and how you thought about doing the data analysis. Also important is the documentation of the code. I will be looking for comments in the source code that explains some of the intuition behind the design choices you've made. If you have a piece of code that prints hello world and the comment above the code says the below code prints hello world, then that comment is really of no value. However, if you're using a particular array or data structure and you provide a comment above it as to why you've chosen that data structure over another one, then that really shows me you know what you're doing and builds credibility around your work. Lastly, aesthetics don't matter too much to me. If you have a menu system that is text on a browser, I don't particularly mind as long as it's clear to me what is what and what does what. I'm not interested in how attractive the user interface is, but how much analysis is provided to me as a user of the application. The first 3 assignments will have 3 items that need to be incorporated when submitting the assignment. The first is the URL to a private GitHub repository that has the source code for your assignment submission. This link is what you will be submitting to me in Blackboard under the assignment description. In your repository's README file, you must have a URL to a Docker image sitting on Docker Hub that I can pull, run, and immediately see your application without any significant prep or setup work. Also in the GitHub repository, there should be the Docker file used to create the image. I will choose a random sample of Docker files and attempt to build the image to verify that the Docker files do work. Please remember that Docker file must sit inside of a private GitHub repository for that assignment, and each assignment has its own private repository. The final project is a team-based activity. We'll talk about how to assemble a team in a few seconds. For the final project, you can use Python, R, or Java, or with my approval, any other language. I'm familiar with 10 to 15 different languages, so unless it's some esoteric language, I will most likely approve. The object of the project is to find a large data set and creatively perform some data analysis and then present that analysis. You may wish to employ machine learning algorithms or use computer vision techniques. I'm not looking for trivial work like plotting the price of a stock on an XY graph and calling it data analytics. I'm looking for some depth and value, something new and interesting. I will have a list of large data providers that you can use to pull data sets from, ranging from financials to images. Each team will submit one and only one submission, and all members will get the same grade for that project, regardless of how much each team member may or may have not contributed. Prior to embarking on the final project, I will ask that you submit a proposal for the project. The proposal should contain what datasets you will be using and what you will be looking to accomplish with that dataset, what techniques you plan to employ, and of what benefit it may be to a user. Each team will have a team leader. The team leader has only 2 responsibilities, which is to submit the proposal and submit the assignment. Who actually leads and runs the team is up to you. When you submit the proposal, please submit it to the Blackboard discussion forum. A team must contain no less than 2 members and no more than 3. Teams should form on their own. If a single person is left without a team, I will have to force assigned teams, which I'm reluctant to do. So if a class has 25 people and 12 pairs forming into teams, that means that the last person has no team will force some team reassignments. Office hours will be held every other week as long as there is an interest to hold it. We will be using the Blackboard Collaborate tool to conduct the office hours, so please make sure your computer is capable of running the tool and your webcam is compatible. That covers the curriculum and the main things you need to know about this semester. Here's a quick slide on my background. I have over 15 years of experience in technology, finance, real estate, entrepreneurship, and also am doing my second master's degree in artificial intelligence, and I'm enjoying every minute of it. If you'd like to contact me, here is my email address and my LinkedIn and Slack ID. Finally, some quick advice for you, particularly if you're new to online learning. First, watch all the videos as early and as much as you can. This will help you ramp up for the course. Although it is possible that not all videos will be available at the beginning of the semester, try to get to the videos that are. Second, read the assigned chapters. The quicker you get through those chapters, the more you'll be prepared to handle the assignments. Third, be active on Slack. I expect a ton of information to be exchanged over Slack, and that can create opportunities for you to learn something in 3 minutes that may have taken you an hour on your own. Finally, I can't stress this enough, stay organized. If that means creating a Data 602 folder and subfolders for each assignment on your computer, then do what is best for you. Organizing yourself in the beginning of the semester will pay dividends throughout the semester and allow you to pace yourself. If you'd like to check out my machine learning playlist to play while you're cranking away some code, check out the list right below this video.